In this video, we're going to explore how gamma works in a specific example where we're going to look at the delta hedging. So we're going to purchase 10,000 100 strike call options with a maturity of 1 year. These cost $104,505.84. In this video, I'm going to always borrow the cash or invest the cash that I've generated from trading. I don't strictly need to do that in these videos, but if we ever get to the point of talking about moving time forward, thinking about the passage of time, it's important to pay attention to our cash and invest it or borrow it if we need it. So we'll do that here. In order to buy these options, we needed to borrow, or we will need to borrow $104,000 in cash. So I will borrow that money for a year at 5%, the risk-free rate. This does nothing to our present value, but now you can see we have no cash in our position. So this is our portfolio. And what I want to explore here is how gamma works, how we think about the profit and loss due to gamma. So first I'm going to hedge our delta. The delta is 6,368 shares. We're going to sell those shares. I am, in this video, going to buy and sell fractions of shares. We could come up with roughly the same answers if we didn't do that, but it does make the math a little bit easier. So we've hedged our delta. You can see now the delta in the portfolio is 0. We sold 6,368 shares. That has generated a lot of cash for us. You can see $636,000 in cash. I'm going to go ahead and invest that, and I'm going to invest that for a year. Again, that doesn't really matter, but it's just nice for our bookkeeping. So now we've got a portfolio. It's got 0 present value. The delta is 0. The gamma is 178.47. Again, gamma units, the easier one to conceptualize. That means if the stock moves by 1%, 100 up to 101, we would expect the delta to change by 178 shares. Now let's look at our portfolio a little bit, update our chart. Let's look at the value chart first. This is our classic delta hedged portfolio. We're sitting at the bottom. We have a positive gamma, which means it is a convex function or concave up function. Let's look at our delta for a second. Change this to a delta graph. You'll see right now we're sitting at a delta of 0. If the stock goes down, the delta becomes negative. If the stock goes up, the delta becomes positive. And let's look at the gamma. The gamma in this position is positive. Again, as we know, 178.47 right now. Let's go back to that delta for a second. We are sitting at a delta of 0, and when the stock goes down, our gamma, positive gamma, makes the delta become negative. And that's a good position to have. A negative delta when the stock is falling means we're going to make money. Again, a positive gamma as the stock goes up, that's going to make our delta positive. And again, a positive delta as the stock goes up is a good position to have. So basically our position works for us. Now the next thing to think about with gamma, and this comes back to our calculus, but if we think about our gamma a little bit, and remember our calculus, and remember something called the Taylor expansion, the Taylor series, we know that if we're going to change spot, the P&L, the change in present value, due to gamma is 1/2 times gamma of the portfolio times the change in spot squared. Now the gamma of the portfolio here, this is a mathematical construct, and so we're going to use the gamma notional, which is the actual derivative. Again, for us right now, it doesn't really matter. Now in the bottom left of my spreadsheet, I have a predictor, and this predictor for changes in spot uses the delta and the gamma. The delta is 0, so we predict no P&L, whatever happens. But we're going to use, you can see our formula, 1/2 gamma times change in spot squared. So here, if we think the spot, starting at 100, is going to go down $5, we predict that we will make $2,231. If I look at my chart for value, we're working our way up this value graph to about here, and that should be a couple $1,000. So let's see what happens. We change spot to 95, and we make $2,444, which was about right. Again, if you remember our delta hedging strategy, what are we supposed to do? We are supposed to rebalance our delta hedge. In this case, buy 995 shares. So I will buy the 995.71. Again, I'm buying fractions of shares in this. Delta is now 0, and we have locked in $2,444. If we update our value chart, we'll see we've shifted to the left. The bottom of this smile is now at $95 rather than at $100 where we started. But second, we've shifted up. The bottom, the Y value or the portfolio value at the price of 95 is $2,444. Now, we can make the market go back up $5. If we look at our prediction, we predict that we should make $2,486. Stock goes back to 100. We make, it's a little hard to see in here because we haven't kept track of the other number, but we make approximately $2,534. Again, what are we supposed to do? We're supposed to rebalance our hedge. We sell shares, the same 995.71 shares at $100, and we've locked in our profit. If we update the chart, it looks a lot like the first chart we started with. The bottom is now at 100, but you can start to see the level, the portfolio value is creeping up. It's now, we've locked in the $4,978.55. And we can recompute that $4,978.55 in a slightly different way, which is we bought 995.71 shares at 95, and we sold them at 100. We made $5 a share. That gives us $4,978.55. Now, an interesting exercise is to do the same thing over again for short position. And we've seen that when we did the delta hedging strategies. If this were a short position in shares, then each of these movements would lock in losses.